29, the properties of matter. And when we take a look at these are properties of substances. And substances are either an element or a compound. So physical properties, these are the properties of a substance, of an element or compound that can be measured using laboratory equipment or observed typically with our 5 senses. And when we measure or make these observations, we can do so without changing the particle's composition or structure. So when we talk about composition, we're talking about the type of atoms and their ratio that they exist within the particle, and the structure is how those atoms are linked together or bonding. So examples of things that we would observe either measuring or using one of our 5 senses would be the phase of the sample. Is it a solid, liquid, or gas? The color of the sample. So is it a Roy G. Biv, like red, orange, yellow, green, blue, violet, or does it lack pigmentation? So we would say it is colorless. So water is colorless. It lacks pigmentation. We can look at the density. We can make measurements and determine the density of the sample. We can look and see if it has luster, meaning is it shiny or is it dull? Can we take a hammer and pound this sample into a thin sheet or shape it? So is it malleable? Or when you hit it or put pressure on it, does it crush and crumble? So, or is it brittle? What happens when you put the material in water? So we can look at whether it is soluble or does not dissolve, insoluble. Does it conduct? So does it conduct heat? Does it conduct electricity? Or does it conduct both? Special temperatures. So what we can observe the melting point, and the other special temperature would be the boiling point. Are there others? Absolutely, but these will get you thinking on typical physical properties in chemistry class. Whereas chemical properties of an element or a compound, they can only be observed during a reaction. So during a chemical reaction. So that means the only time that we observe this type of properties in a reaction, and it results in a change. So it results in a change in the composition and structure. So that means the type of atoms or their ratio and how they're bonded is changed. So whatever substance we start with, it's not the same substance we end with. So examples. Does a material burn or is it flammable? Are we able to bleach it? Does it sour? Does it ferment? Is it involved to be able to neutralize another material? Its level of activity. Does it react? Does it decompose? Would be major buzzwords that we're looking at a chemical property. However, there is one chemical property we need to list, and it's this funny word, inert. So if something is inert, that means that it fails to react or it doesn't react. So it doesn't react. It's a material with very low activity. So the thing is if a substance is inert, it's kind of boring. There's nothing exciting going on. However, it's very, very important. So examples of materials that tend to have low activity, they don't react very often, would be material like water. So water a lot of times is a medium or the host in which a reaction takes place, but it doesn't participate. It's kind of like a beaker in our body. Nitrogen gas. The largest component of every breath that you inhale is nitrogen gas, probably around 70%. And it does not inhibit or participate in our body's respiration. And another one, this is why it's so valuable, is gold. Gold is pretty inert, it has low activity. So you can take a nugget of gold, dump it in the ocean, and it doesn't rust like other metals. So it maintains its value. So a material that is inert is kind of a boring chemical property, but nonetheless important.